Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear doubts. Friends, today's video is question number 2.49 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's check the question. Lifetimes of a molecule in the excited state are often measured by using pulsed radiation source of duration nearly in the nanosecond range. So they are telling for any molecule which is in excited state, we can calculate the lifetime by the radiation source pulse which is sent in the duration of nanosecond, means very small piece of time. Now the actual part of the question is, if the radiation source has the duration of 2 nanosecond. Now in this case, they are telling the duration of time is 2 nanosecond and the number of photons emitted during this pulse source is 2.5 into 10 to the power 15. Then calculate the energy of the source. So friends, first of all we will write whatever is given. So first thing which is given is time which is denoted by T. We will write it here 2 nanosecond, which we will convert to the second, 2 into 10 to the power minus 9 second, because we knew that 1 nanosecond is equal to 10 to the power minus 9 second. Now next thing is given number of photons. It is 2.5 into 10 to the power 15. Number of photons is denoted by n. We'll denote it here with the small n. Now they ask calculate the energy of the source. So as we knew, the energy of one photon E is equal to h mu. So the energy of all the photons, it means the total energy, we can mention ET also. Energy total, T-O-T-A-L. Total energy will be N into h mu. Number of photons multiplied with the energy of one photon, we will get the total energy. And here we need to calculate the energy of the source, it means the total energy. Now here N is given, h is a Planck's constant, but mu is not given. Mu is the frequency. Now one thing what we should know is that frequency mu is equal to 1 upon time. From here we can calculate the frequency. So time is given 1 upon 2 into 10 to the power minus 9 second. So we can write frequency is equal to 0.5. 1 by 2 is equal to 0.5 into 10 to the power 9 per second. This is the frequency. Now we'll substitute the values in the formula, that is energy of the source. Energy of the source, which is denoted by ET, is equal to N, H and mu. Now N is 2.5 into 10 to the power 15. H is a Planck's constant, 6.626 into 10 to the power minus 34 multiplied by frequency mu, and value is 0.5 into 10 to the power 9 per second. Now Planck's constant, its value is 6.626 into 10 to the power minus 34 joule second. Now start doing calculation. Second and per second will be cancelled. First collect all the numbers. 2.5 multiplied by 6.626 multiplied by 0.5 into 10 to the power 15 into 10 to the power minus 34 into 10 to the power 9, and joule is left over here. Now after doing the calculation, we will get the value of it is 8.28 into 10 to the power. Now adjust the values of the power. 15 plus 9, it is 24. So minus 34 plus 24, it become minus 10. So we can write 10 to the power minus 10 and joule. So this is the answer. The energy of the source is 8.28 into 10 to the power minus 10 joule. So friends, question is easy. It's looking big, but it is very easy and very short. Only energy formula is applied here. So friends, keep on studying. Please like, share and subscribe the channel, and don't forget to press the bell icon so that you will be there with me with the next coming video. Till then, thank you.